quadratic equations by the square root method. And I talked about this a little bit the other day. And here's the deal. We learned how to solve some quadratic equations. For example, we could solve x squared minus 4x minus 12 equals 0. That's a quadratic equation that we can solve. How do we solve quadratic equations at this point? We get 0 on one side, and then we factor. This one already has 0 on one side. That's great. Can we factor? Yeah, this one factors as x minus 6, x plus 2 equals 0. So we get x equals 6, x equals negative 2. If I were to change that problem ever so slightly, make it x squared minus 4x minus 13 equals 0, that doesn't factor. That's prime. And many quadratic functions, like this one, are prime. You can't factor them. It doesn't mean that there's no answers. We could graph this on our calculator, and we could see that there are answers. Let's see. X squared minus 4x minus 13. Graph looks something like that. Where are the answers? At the intercepts. Where does it equal 0? It equals 0 right there and right there. And what you might notice about the answers is they don't fall right on a tick mark. They're close. There are answers. They're just not nice numbers. So we're going to spend the next few sections learning how to solve quadratic equations that won't factor. Now, unfortunately, we won't be able to solve this one today. We'll come back to this one. We'll be able to solve this one early next week. Well, let me give you another example of one you can solve and one you can't, and we'll talk about how to solve this one. What if I gave you x squared equals 25? Could you solve x squared equals 25? I would hope so. What would you do? Square root it, and you would tell me x is 5, and you're half right. And negative 5. There should be two answers, shouldn't there be? All right, so what we did in the past is we moved the 25 over, and then we saw that x squared minus 25 factors. That factors as x minus 5 and x plus 5. So we got our two answers. X is 5, x is negative 5. Another correct way to do this problem is what was suggested. And what was suggested was square root it. What do you mean by square root it? Square root both sides. Just like we can subtract 25 on both sides, we can do square root on both sides. The only thing you need to remember when you do square root on both sides is that 25 has more than one square root. What are the square roots of 25? 5 and negative 5. So when you do square root on both sides, we write that symbol. And that symbol reminds us that there are two square roots. There are a positive one and a negative one. So quite often we would write our answer as x equals plus and minus 5, because the square root of 25 is 5. So this symbol, x equals plus or minus 5, means exactly the same as this. It means x could be 5, x could be negative 5. Shorthand way for writing that. Well, that's helpful, because that now allows us to solve some quadratic equations that won't factor. For example, if I were to change that ever so slightly and just write x squared equals 24, if I move the 24 over, that doesn't factor anymore, because 24 is not a perfect square. However, I can solve it. How do I solve it? I square root on both sides. And once again, I remember that there are two of them, a positive square root and a negative square root. My answer could be x equals plus or minus the square root of 24. Now, as far as I'm concerned, that's a perfectly acceptable answer. I don't mind that. However, when you go to do your extra credit work on MyLab, you go to do your homework, MyLab's not going to take that answer. Why not? It wants all square roots simplified. That's correct. And that's why we did that section the other day on simplifying square roots. How do you simplify the square root of 24? And I don't mean just plug square root of 24 into a calculator and give me an ugly little decimal. 2 radical 6. Because what you're going to do is you're going to recognize that 24 factors as 4 times 6. And the square root of 4 is a nice number. The square root of 4 is 2. So we would write our final answer as plus or minus 2 square root of 6. Questions on that? How about x squared equals minus 81? How would you solve that equation? I could add 81 over to the other side, that's true. But unfortunately, if I do that, x squared plus 81 equals 0. In order to factor, we would need to have x squared minus something. This is sum of squares, that's prime, that doesn't factor. So unfortunately, moving the 81 over isn't going to help. What could we do instead? Square root it. All right, so that didn't help. Not wrong, it just didn't help. X squared equals minus 81. Square root both sides. Remembering that there are 2 of them, a plus and a minus. Our answer would be x equals plus or minus 9i. Excellent, 9i. We saw that we have a negative under our square root. When we have a negative under our square root, we're going to get a complex answer. And again, that can happen. That's why we talked about complex numbers. But you know something I just remembered? MyLab doesn't accept answers like that either. MyLab doesn't have a plus or minus button on it. When you go to do MyLab, you're going to have to write, it'll ask you to give 2 answers. So in MyLab, you'll have to write it that way. X equals 9i, x equals minus 9i. On a quiz, on a test, perfectly acceptable to leave it like that. But if you're working in MyLab, it's going to want 2 answers. Even for this one back up here, you would have to type in 2 answers. You'd have to type in x equals 2 square root of 6 and x equals negative 2 square root of 6. It forces you to write them separately, unfortunately. Okay, how about x minus 3 squared equals 5? How would you solve that equation? Okay. Here's the wrong thing to do. We FOIL. If I FOIL, I have to take x minus 3 times x minus 3. And I FOIL that out, I'm going to get x squared minus 6x plus 9 equals 5. And then what do I have to do? Subtract 5 to get 0 on one side. X squared minus 6x plus 4 equals 0. And now I'm in big trouble. Why am I in big trouble? Because that doesn't factor. Okay? The truth is, in most situations, FOIL is a very bad thing. FOIL is a 4-letter word in math. Bad thing. You don't want a FOIL in general. If FOIL is a bad thing, why do we teach it? Not really. The only reason we teach FOIL is so you can do backward, which is called factor. So before you can learn to factor, you need to understand how to multiply. FOIL is a way for multiply. But in general, if you have something set up like this, doing FOIL is a bad thing. You almost never want to FOIL. You always want to factor. Unfortunately, this doesn't factor. Here's what you want to do instead. You want to square root it. If you see a parenthesis like this with a square, that's a good thing. Because you can leave the parenthesis, you can put the parenthesis on one side, and you can get rid of that square. How do you get rid of that square? You do a square root. And once again, we're going to remember there are two square roots, a positive one and a negative one. We end up with x minus 3 equals plus or minus square root of 5. How can you get the x all by itself? Add 3. So we would write our answer as x equals 3 plus or minus square root of 5. Correct. And again, if you're doing this on MyLab, it's going to force you to write two answers. You're going to write x plus the square root of 3, or I'm sorry, 3 plus the square root of 5, and 3 minus the square root of 5. MyLab will force you to write two answers. Questions on that? All right, how about 3 times 2x plus 1 squared equals, I don't know, I need a good number. Anybody got a good number? 21. 21 is a good number. Okay. What would you do? And the wrong answer is FOIL. FOIL is almost always the wrong answer. Square root both sides is a great idea, but there's one thing you need to do before you square root both sides. Not subtract by 3, but rather divide by 3. Right, you want to get the parenthesis thing all by itself. We divide by 3 because that's connected with a multiply. So what you want to do when you see these parentheses with a square, you want to get the parenthesis by itself. So in this case, we have to divide by 3. Now that we have the parenthesis all by itself, what do? Now we square root. Remembering, as always, that there are two square roots, a positive and a negative. We're going to have 2x plus 1 equals plus or minus square root of 7. What would you do now to get the x all by itself? Subtract 1, and we write it as 2x equals negative 1 plus or minus square root of 7. And finally, divide by 2, and when we divide by 2, we do it everywhere. Negative 1 plus or minus square root of 7. And typically, we just write it that way. We divide the whole thing by 2. Questions on that one? All right, let's do a couple more. How about negative 2 times 3x plus 1 squared plus 5 equals negative 33 maybe. What do? How do you solve that equation? You're going to subtract the 5 and then divide by negative 2. Excellent. What he's doing is he's doing a couple of steps to get this piece all by itself. So that's where you want to start. When you see a parenthesis with a square on it like that, you want to do a couple steps to get that piece all by itself, and then you'll be able to square root. In order to do that, we subtract the 5. So we have negative 2 times 3x plus 1 squared equals negative 38. We divide by negative 2. Negative 38 divided by negative 2 is 19. Yeah, you're close. 19. All right, so there's your first couple steps. First couple steps are get the parenthesis thing by itself. Why do you want that parenthesis thing by itself? So you can square root. All right, so we square root both sides. We have 3x plus 1 equals square root of 19. Plus or minus, thank you. I was hoping somebody would catch that. And that's probably the biggest mistake people make. People will forget that there has to be two answers. You got to remember that plus and minus every time. That's probably the biggest mistake people make. All right, so now we subtract the 1. 3x equals negative 1 plus or minus square root of 19. And finally, we divide by 3. Negative 1 plus or minus square root of 19 over 3. Questions on that? Yes?
What if the negative 1 was a 6? Would you simplify?
If the negative 1 was a 6, so if my answer turned out to be 6 plus or minus square root of 19 over 3, can I simplify? So a completely different problem. Can you simplify that? What you can't do is just take the 6 and the 3 and divide them. If you're going to divide, you need to be able to divide everywhere. What you can do, however, if you want, is you could split this. You could write it as 6 over 3 plus or minus square root of 19 over 3. And then 6 over 3 is 2. So you could write it as 2 plus or minus square root of 19 over 3. But the point is the square root of 19 still has to be divided by that 3. I personally wouldn't care which way you wrote it. If I were doing it, I would leave my answer in that form myself. But that's up to you. All right, I want to do one last problem. And the last problem is this. 4x minus 3 squared equals 36. Sometimes the answers do come out nice, and this is a good example. You don't always get answers that have ugly square roots in them and ugly fractions in them. Sometimes your answers can come out nice. Why is this one going to come out nice? Because 36 is a perfect square. When I do square root on both sides, I get a nice answer, don't I? I have 4x minus 3 equals plus or minus 6. When the answer comes out nice, when the square root goes away like it did here, typically what we do then is we split it into two answers. We write 4x minus 3 equals 6, 4x minus 3 equals negative 6, just pretty much like we did when we factored. And then we solve and we get two answers that way. So this would be 4x equals 9, x is 9/4, and 4x equals negative 3, x is negative 3/4. So if that square root happens to come out to be a real nice number like 6, typically we split, solve each one individually, and get our two decent answers that don't have any square roots in them. And it turned out they still have fractions. That happens. But at least there were no square roots. Questions on that?